Hello friends, in this video I am discuss about the amines in class 12 in organic chemistry. Okay, what is amine? Amine is ammonia derivatives obtained by replacing one or two or three hydrogen from the ammonia. That's mean if it is ammonia, then its derivative, that's mean if we remove one hydrogen and will attach in place of one hydrogen, if it is R means alkyl group, that's mean CH3, C2H5 or phenyl group. Okay, it may be, that's mean it may be like this. So in place of one hydrogen, if we attached a phenyl group, then it will be phenylamine. That's mean actually this is the name of this compound is aniline. Okay, so if we remove 3 hydrogen by 3 methyl group, then it will be trimethylamine. Okay, so in this way we will get the ammonia derivative. Okay, and classification of the amine is that primary, secondary, tertiary, or 3 degree amine. Okay, and this is primary amine, this is 3 degree amine. Okay, no problem. So nomenclature, what will be the nomenclature? In common system, the aliphatic amine is named by the prefix alkyl group, that's mean alkyl amine. Okay, so this is alkyl amine. If we say that RNH2, it is primary amine. Primary means it is nitrogen contain one carbon containing group directly attached with one carbon. So this is primary amine. This is 3 degree amine. Okay, because this nitrogen contains 3 carbon. Okay, or that alkyl amine. This is alkyl group, so this is alkyl amine. In this way, it is nomenclature is done. Okay. And structure, what will be the structure? Nitrogen contains 5 electron. Nitrogen contains 5 electron in its outermost shell. That's mean lone pair, and there is a R. Okay. So for this region, that is actually 1, 2, 3, and there is a lone pair. So there is a bond lone pair. So one s orbital, one p orbital, another p. So this is sp3 hybridized orbital. So the sp3 hybridized compound is this, or the ammonia is sp3 hybridized or trimethylamine, or 3 degree amine is always sp3, and ammonia is also sp3 because there is a 3 bond pair and 1 lone pair. Clear? So this is the structure of amine, and bond length must be less than 109 degree 28 minutes because there is a lone pair, bond pair, some repulsion is there. For this reason, bond will be close to each other. It is not perfectly tetrahedral. If it was perfectly tetrahedral, the angle should be 109 degree 28 minutes, but this is the distorted tetrahedral. For this reason, the angle of this, or that RNR, this angle will be less than 109 degree 28 minutes. Clear? Now, what is the properties of the amine? It may be physical property, it may be chemical property. Physical state, it is lower aliphatic amines. Lower aliphatic amines means like this methylamine, ethylamine, this type of propylamine. This type of amine is gaseous, and then more than 3 carbon containing amine is liquid, and its odor is fishy like. Okay, that's mean মাছের গন্ধের মতো. Okay, and color, actually color of the amine is colorless, but when it is oxidized it may arise some color, no problem. And solubility, what is the solubility? Solubility of the amine in water is very likely that's amine is polar compound, that's mean ammonia or any amine is polar compound, and water is also polar compound. For this reason amine dissolve in water. Okay, and boiling point, what is the boiling point? Amines being polar, since it is a polar, it forms intermolecular hydrogen bond. Okay, form intermolecular hydrogen bond and exist as the associated molecules, because amine, that is amine. Okay, if it is lone pair, then dot dot dot, if amine hydrogen is there, so lone pair and hydrogen, this is delta positive, delta negative. Okay, R, or again lone pair, dot dot dot, Is, N, R. In this way there are association, intermolecular hydrogen bond is there. So for this reason the boiling point is high for amine, and the boiling point order must be equal to boiling point order 1 degree greater than 2 degree greater than 3 degree amine. Okay, so boiling point of 1 degree is higher than 2 degree than 3 degree amine, because in 1 degree amine there are strong hydrogen bond. For this reason the boiling point will be increased. Clear? And now how we can prepare amine? How we can prepare amine, or the preparation of amine? Okay, preparation of amine, preparation, how we can prepare? That's mean preparation of amine. Okay, তো আমরা কিভাবে প্রিপেয়ার করতে পারি? From the RNH2 RNO2, that's mean nitro group. From the nitro group or the nitroamine, from the nitroamine or nitro compounds we can prepare amine by reduction. If SN-HCl, that is a metal in HCl, and or we can also use another lithium aluminum hydride is a reducing agent, then we can get RNH2. Okay, in this way we can get amine from the nitro compound. Clear? So from the preparation of amine from the nitro compound, that's mean from the nitro compound, if we reduce the nitro group by SN-HCl, that is thin hydrochloric acid, heat, or by lithium aluminum hydride, then we can get primary amine, no problem. Okay, in this way we can get primary amine. And Hopman aminolysis, by Hopman aminolysis, the second process is Hopman aminolysis. Hopman aminolysis. Hopman aminolysis. What is the Hopman aminolysis? Hopman aminolysis is, that's mean that Rx. What is Rx? Alkyl halide. Okay, this is the alkyl group, this is a halide. That's mean RCl. It may be, no problem. So in this position, if we use ammonia, then HCl will remove and RNH2 will be formed. Okay, so by the Hopman aminolysis we can prepare from the alkyl halide, we can get alkyl amine. So this is the second preparation. And what will be the third preparation? That's mean in this way we can, so many ways we can prepare amine. And Mendeus reduction. What is the Mendeus reduction? Mendeus reduction, that's mean RCN. What is RCN? That's mean alkyl nitrile. From the alkyl nitrile there is C triple bond N. So from the, or cyanide, alkyl cyanide or alkyl nitrile. This alkyl nitride can be treated by lithium aluminum hydride, no problem, lithium aluminum hydride, or we can treat it with sodium amalgam in alcohol, or sodium amalgam in ethanol. Okay, lithium aluminum hydride or sodium amalgam in ethanol, then we will get our CH2 NH2. This nitrogen, 2 hydrogen will introduce in this nitrogen and 2 hydrogen introduce in this carbon, then it will form our CH2 NH2. So hydrogenation reaction, that's mean reduction of alkyl nitrile. Okay, so from the alkyl nitrile we can readily get amine. Okay, now this is known as Mendius reduction. This is known as Mendius reduction. Now reduction of amides, by the reduction of amides, that's mean amide. What is amide? Amide R C double bond O NH2. This is known as amide. What is this? This is known as amide. So from the amide, how we can get amine? How we can get amine? This is also we can get from this position. We can also get by lithium aluminum hydride. We can reduce this. We can also reduce this type of compound by lithium aluminum hydride or sodium in alcohol, then also we can get our CH2 NH2, no problem. Okay, so this is very important process. From the amide we can get amine. Okay, now there is a very important process, and it should be remembered always, that Gabrielle Calamite synthesis. What is this? Gabrielle Gabrielle Calamite synthesis. What is Gabrielle Calamite synthesis? What is this? This is actually phthalic acid. If we heat it with P2O5, then we will get phthalic anhydride. What? Phthalic. One water will be removed from here. Okay, sorry. One water will be removed from here. Okay, so we will get phthalic anhydride. This is known as phthalic anhydride. Now this phthalic anhydride is treated with ammonia. If it is treated with ammonia, then we will get NH. Okay, from ammonia, 2 hydrogen and this oxygen, then water will be removed from here, and then we will get this amide. Okay, now from this amide, if we use potassium hydroxide, then what happen? If we use potassium hydroxide, then water will be removed. N minus K plus, this is OH minus will take this hydrogen, then it will get amide ion. Okay, now if we use that any alkyl halide RX or RCl, it may be RX, X means halide, X equal to chlorine, bromine or iodine. Okay, then what happen? This negative charge will attack this positive center and this negative center will be removed. Then I will get, what happened? This is double bond O, nitrogen, double bond O, nitrogen, and here this R will be attached. Okay, now after hydrolysis, that's mean if we treat this system with OH minus solution or acid solution, then we will get, that's mean it is hydrolysis, this bond will be removed, that bond will be removed, and this R NH2, okay, will be formed. That's mean C double bond O, OH, C double bond O, OH plus R N H2. So what happened? That's mean OH minus will attack in this side, this bond will be, this minus will attack in this side, then bond will be here. So this is OH minus, and again OH minus attack this position, it will be removed, and from the solution system it will take to hydrogen. That's mean actually this hydrogen will shift towards this, and there is a potassium, so there will be K plus O minus, K plus O minus. Okay, so in this system we will get RNH2. So this is very important because Gabrielle Calamite synthesis is very important in this chapter. Okay, so this one is very important for preparation of primary amine. Clear? And from the Hopman bromide degradation reaction, Hopman bromide degradation or bromamide degradation reaction. So from the Hopman bromamide degradation reaction we can get primary amine, that's mean R C double bond O NH2. This is amide. Okay, if we use bromine in KOH, this reagent is known as Hopman bromamide reagent. Hopman bromamide reagent very important because this step is using for step down reaction. We will get RNH2. In everywhere if we use bromine in KOH heat, then this portion will be removed and RNH2 will be there. Okay, this is very important reaction, Hopman bromamide degradation reaction or Hopman degradation reaction is this reaction. Okay, in this way we can prepare primary amine. Okay, and for Gabrielle Calamite synthesis there was a limitation. It is used for preparation only primary amine, will not use to prepare secondary or tertiary amine for the Gabrielle Calamite synthesis process. Okay, Gabrielle Thalamite synthesis process only we can use for the preparation of primary amine. Then chemical, we already discussed about the physical property. Now what will be the chemical properties? Basic character is there. Since ammonia derivative is it, okay, there is a lone pair. This lone pair can donate, or this can act as a Lewis base. Okay, so all amine is basic amine. Okay, so amine is basic in character. So aliphatic amines are strong bases, okay, due to plus I effect. This is R contains a plus I effect. Okay, so primary amines always more basic than secondary than tertiary. Okay, and aromatic amines are weaker base than ammonia due to negative effect. That's mean if it is aromatic, if aromatic is there, then this lone pair can participate in the resonance reaction, resonating structure or delocalization of this lone pair towards the benzene ring. It will not donate to the outside. Okay, so this aromatic amines is less basic. Clear? So aromatic amine is less basic or weaker base than aliphatic amine. No problem. In gaseous phase, the order of basicity changes. It will be in gaseous phase always 3 degree amine greater than 2 degree amine greater than 1 degree amine. In gaseous phase, basicity order of amine. Okay, in gaseous phase it is always 3 degree amine is more basic than 2 degree than 1 degree. It should be remembered. And in aqueous phase, the basicity of amines, this is actually C2H5 whole to NH2 greater than, we can write in this way, C2H5 whole to NH, okay, then this is greater than C2H5 whole 3 N. So this is a 3 degree amine and this is 2 degree amine. But why the basicity of 2 degree amine is greater than 3 degree amine? I will explain it. Greater than primary amine, that's mean C2H5 NH2, okay, greater than ammonia. Ammonia is basic, but when alkyl group is there, positive, that is C2H5, this group NH2, there is a positive or I effect, that is positive I effect plus I effect is there, then lone pair density of the electron on the nitrogen will be increased, then basicity will be increased. There is a 2 alkyl group, so R, this is R, nitrogen, R, there is a 3, okay, but why this is? Why R compared to this is 3 degree, this is 2 degree. We can assume that there is a 3 plus I effect, so electron density will be more than 2 degree amine. But why this is more basic than this? Because it can donate, but it is unable to donate because there is a steric crowding. Because there is a steric crowding, if it can donate a positive to the positive charge, then they will not allow this, because there is a steric crowding. So since the number of alkyl group is more, for this reason, for the crowd system, this lone pair is unable to donate. So it is less basic than secondary amine. Okay. So in this way we can compare the basicity of amine. There are so many examples. Okay. Now chemical reaction, we already prepared that amine, how we can prepare amine. Now how we can react, how we can see the reaction of amine. They can react RNH2, this is primary amine, so it can react with different substances or different reagent. Okay, if we see that if there is a H cell, then we can get readily this lone pair can take H plus ion, then RNH3, that will be plus because this lone pair is donated, and Cl minus, so salt like structure. Okay, this is salt like structure. If we use again sodium hydroxide, then this HCl will remove and we will get again this amine. Okay, so if we use HCl, then we will get salt like structure, and if we use sodium hydroxide in this salt, then again we will get back primary amine. Okay, now what happen if we use RNH2, if we use R-Cl or R-X, then this lone pair can again attack to this position, then chlorine can be removed, then we will get Rn plus, that is R-H. Okay, so nitrogen is there, so nitrogen plus Cl minus, then this HCl can remove, then it will be RNH R-. Okay, so this type of compound we can form. And again if we use another R-Cl, double dash means it may be alkyl group, methyl group, ethyl group, no problem. Then we will get RN R-R', okay, plus HCl. So in this way the primary amine can react to form tertiary 3-degree amine. Okay, to form 3-degree amine. Now what happen if we use acid chloride RNH2, there is a lone pair acid chloride. What is the acid chloride? RC double bond O Cl, this is the acid chloride. Then this lone pair can attack to this position, chlorine can remove. Okay, then we will get Rn, this chlorine will remove with a hydrogen, then there will be carbon C double bond O R. Okay, so this compound may be formed, no problem. Clear? This is amide bond. Okay, so we can form amide from acid chloride to primary amine can react with acid chloride to form amide. Okay, now if we use nitrous acid, then we can get, let us consider H2 nitrous acid. What is this? Nitrous acid. If we use nitrous acid, then we will get ROH. Nitrogen will be removed. Okay, nitrogen will be removed completely from this system. Okay, so using nitrous acid we can form alcohol from the primary amine. Clear? Now, if we use thionyl chloride, or what will be the reaction? That's when if we use C6H5, SO2Cl. This is very important. Plus RNH2. Okay. Then what happened here? From H and Cl will remove. We'll get C6H5 SO2 NH. Then this is or actually O2S C6H5. Okay, or we can write in this way that C6H5 SO C6H5 SO. Okay, that's when here is SO2. Then this portion, that's when this portion NR, there is a hydrogen. So this can be formed readily, and this reaction is known as Hinge-Burke reaction. So what is the Hinge-Burke reaction? Hinge-Burke reaction is very important reaction. Hinge-Burke reaction. Very important reaction for your board and as well as for competitive exam. Why it is so important? Because from this Hinge-Burke reaction we can detect primary or secondary or tertiary amine. So detection of primary or secondary amine, we use Hinge-Burke reaction. So what is the Hinge-Burke reaction? The reagent is C6H5 SO2Cl. Okay, this is very important. Benzene sulfonyl chloride. This is the benzene. Structure is like this. Benzene sulfonyl chloride. Okay, this is the reagent of Hinge-Burke reaction. Very important. And using this we can use RNH2. This, if it is primary amine, then what happen? C6H5 SO2 NHR. C6H5 SO2 NHR. That is one hydrogen and one chlorine will remove. So primary amine always give this type of reaction. Okay, and with the potassium hydroxide or sodium hydroxide, it will give C6H5 SO NR. This is very important. Okay, this will be minus and potassium will be plus. So water will remove. Okay, so very important this reaction. Clear? So primary amine we can get this type of from salt from the primary amine. That's mean N-alkyl amine actually. N-alkyl benzene sulfonylamine. So this is very important, and this is soluble in alkali. This compound is soluble in alkali. Okay, for this reason it is very important. But from the secondary amine, if we use secondary amine, that's mean RNRH. This is the secondary amine. Okay, then we also can get this type of reaction, that means C6H5 SO then NR. ACE and Cl can be removed, but this is actually insoluble in alkali because there is no hydrogen. So water can't be removed, or it can't form a salt. Okay, K plus whole minus, there is no possible. Okay, so this is not soluble in alkali or insoluble in alkali. Okay, but if it is tertiary amine, since there is no hydrogen, so HCl will not remove, then there is no reaction. Okay, so this is very important. This is very important reaction. That's been Hinge-Berg reaction. So Hinge-Berg reaction we will use to detect primary, secondary or tertiary amine. Okay, and there is a very important test for aliphatic and aromatic primary amines. Okay, aliphatic and aromatic primary amines, that's mean RNH2 or ARNH2. Okay, primary and aromatic amine react with chloroform in presence of alcoholic KOs. Okay, very important reaction. Primary or aromatic amine can react with chloroform in presence of alcoholic KOs. It will produce RNC. Okay, not RCN. That is RNC. What is this? Actually carbylamine. Okay, so this reaction is known as carbylamine test or carbylamine reaction. Very important reaction. This is very important reaction, carbylamine test. So all primary amines reacts with chloroform in presence of alcoholic KOs to gives carbylamine. This is very foul smell from the carbylamine. The foul smell is coming. Okay, for this reason, this is very important reaction to detect the carbylamine, because we will get the foul smell from this compound immediately. Okay, so and there is another reaction to detect primary amine, which is known as azodite test. Only primary aromatic amines will give the color with the azodite. Okay, so aliphatic amine does not perform azodite test, but primary amine can perform azodite test. Clear? Now there are so many reactions, that's in electrophilic substitution reaction of aryl amine. What is this? Nucleophilic substitution reaction of aryl amine I will produce in the next lecture, and to give this type of to get this type of reaction, you can subscribe this channel for update, or I will give you time to time the whole syllabus about chemistry. Thank you.